Okay, I'll start by saying what I always say at the beginning of my talk. It is the only diabetes unit anywhere in the world which has mother and baby as the logo. And this has direct relevance to what we discussed just now about genetics and other things, because I believed from very early training that mother's lifestyle, her metabolism influences the baby not only when it's growing in the mother's womb, but for the rest of the life. The second logo, which we acquired much later, is what's wrong with us, and that's the modern Ganesh. The modern Ganesh, like say today, is doing what he's doing just now. When I was young, this Ganesh used to travel on the back of the mouse. Now, given the difference or the discrepancy in the size between the vehicle and the passenger, you can imagine the journey was very slow. Diabetes prevalence was low, obesity was also low. As the time has gone on, this Ganesh now lies down and clicks the mice. Rather than sitting on the back of the mouse, he is clicking the mice. And that is the rapid transition we had in last 50 to 60 years. So based on what you learn when you are in mother's womb, and when the situation later on does not match the expectations, that is trouble. And that, of course, reflects in what has happened to the world over here. I think actually I was trying to get a picture of a front book of book written by my friend Barry Popkin, and he wrote a book called World is Getting Fat. And this is what's happening. This is the increase in the overweight and obesity up to the year 2014 in different countries, and that's the average for the world here. Fortunately, India, in the Asian countries and Africa, have a lower increase in obesity, but as we will soon see, obesity is not equivalent to adiposity. Any of you can tell me what's the difference between obesity and adiposity? Obesity you measure by body mass index. That's weight for height. There's no fat measurement except what is there in the weight. But we still call it adiposity as an interchangeable term in most of the articles. Adiposity is actually body fat percent, and that's a body composition. And I saw outside there is a stall in body company. They're measuring your body fat. I did this 30 years ago on myself, and I got the shock of my life. From childhood, everyone was telling me to put on weight and become good. And I already realized that despite my low weight, low body mass index, I was very fat because my body fat percent was very high. And that's how the term thin fat came. And therefore, then I started saying we must distinguish between obesity and adiposity to get the component right. Otherwise, we are going to go on doing confusion, especially when you compare Indians with other population. So interpopulation comparisons by BMI are a no-go. And I was just now listening to the debate there, and the ADA says this, whatever some other agency says this, based on BMI we do this, that's going to mislead us. This is a very nice paper. All of you should read and acquire this issue of Lancet last year. 5 publications from PHFI, Public Health Foundation of India. I have contributed to diabetes. Today I have restricted to obesity, and they showed that in 25 years between 1990 and 2016, what's the change in different conditions in different states. And worse change is denoted in red, and then the shades follow to the blue. So in 1990, as I said, the old Ganesh-like thing or whatever lifestyle we had, there was hardly any red state. In fact, no red state for obesity. In 2016, we have lots of states which are red, South Indian as well as in North India, and very peculiarly in the Northeast. Now, if you look by affluence and stability of life, the political stability, social stability, there is a big message here. The two types of states which have increased obesity are those which are relatively affluent, more educated, with a better health service. At the same time, states which are in political turmoil, states which have a lot of geographical difficulties, they are also which have shown obesity. And for diabetes, if you see that article, it's very strong. The Bimaru states, do you know the term Bimaru states? So Bihar, Madhya Pradesh, Uttar Pradesh, which otherwise we call them as impoverished states, they have the highest rise in the diabetes prevalence. Therefore, it tells you that your legacy of previous life and the social and other conditions actually influences what happens to you. So genetics of obesity, we just now said genetics of diabetes. It's fashionable to show such Manhattan plots and draw various genes. Of course, genes are involved in everything, because we begin our life as a bag of chromosomes surrounded by cytoplasm, and then that develops into the whole individual, and all that message is contained in genes. So it's not surprising that all the phenotypes are associated with some genes. The problem is the genes which we know today which are associated with obesity or diabetes are very common genes. They are polymorphisms. They are not mutations. Again, I don't know whether you know the difference between polymorphism and mutation. Mutation is a change in gene which is present in very small numbers. This manifestation occurs. And this is the model of polygenic gene. And I have shown this here only to show that genes associated with obesity are strongly linked to your brain centers for food intake. So either orexogenic or the anorectic. And only few genes are related to other organs. The strong influence for this is coming from brain influence. We got into this long time ago. Our first paper was published in 2008. That's with Giriraj Chandak from Center for Cellular and Molecular Biology. And when FTO gene was described by my friend Andrew Hattersley and his colleague Tim Freling, we were part of this consortium. Only thing was, the findings in India were different than the rest of the world. And therefore, Andrew decided in his wisdom to remove the Indian data from the science paper. So I had to publish it subsequently in Diabetology. See what was the difference. The FTO gene, which is the best known gene associated with increased risk of obesity, was actually found out on jivas of type 2 diabetes. So when Europeans were actually subjected to genetic analysis in relation to different phenotypes, FTO was strongly linked with diabetes. But when they adjusted this association for BMI, the association became non-significant. And therefore, it was sold as an obesity gene. So they said the primary effect is on obesity, and then secondarily type 2 diabetes, because type 2 diabetes people are usually obese. What was the difference in Indians? So in our cohort, FTO association with T1, T2D as strong as in Europeans. Here there was 27% increase in risk, 26% increase in risk. You adjust for BMI, and in Europeans, if you were to think like Europeans, you would expect that to go away. You adjust that for BMI in Indians and it just doesn't go away. Therefore, we showed that there was a different genotype phenotype association in Indians for the FTO gene. And this raised many possibilities. It may be that BMI is not a good indication of body obesity, adiposity in our population. One which I favor is that Indians have had a whole lot of detrimental environmental exposure for last few hundred years, like we saw in the last graph, and therefore epigenetically this gene might be modified, and therefore we show the association with glucose, not with the obesity or the adiposity or obesity. Very interesting paper. I was a registrar in 1976 in Bizet Medical College. When I read this paper, I didn't understand a word of it, but I thought something important was being said. This paper was published by a very enthusiastic group who were following up people who were born during the time of what was called Dutch winter hunger. Again, I don't know how many of you know about it. It's a very famous thing which is now converted into a big specialty in medicine. So towards the end of the Second World War, Nazis closed the food supply to Western Netherlands, Holland. And it was an unusually severe winter, so it was a very harsh environmental condition. Everyone had to go on 600 calories per day diet, including the pregnant women. So their babies as if faced a famine in utero. So that is the Dutch winter hunger model. Now, story would have stopped there. That must have increased the perinatal events, mortality, morbidity, etc. But people followed them up later on. So when these people came for army recruitment, what we call conscription, they were studied for their height, weight and obesity. And very interesting things came out. The green line is the level of obesity in the population which was not exposed to intrauterine hunger. So they were born either before or after the Dutch winter hunger. While red line represents people who were exposed to in utero hunger or postnatal hunger. Those who were exposed in utero in the third trimester had a lower prevalence of obesity. Those who were exposed in the first 2 trimesters had a higher prevalence of obesity. So in one study, we know that intrauterine exposure to hunger predisposes either you to obesity or protects you from obesity, depending on which window you were exposed. Brilliant. And the reason for this might become apparent later on, that third trimester, the number of fat cells is finalized, while in first 2 trimesters, the brain centers for food are programmed. So these people come out and continue to behave as if there is hunger, so they eat more and become obese. While these people have smaller number of fat cells, therefore even if they are eating more, they still can't become obese. A little later, paper was published from Pima Indians, another brilliant paper. First author is David Pettit, who is a close friend, but it was driven by Bill Noller, who is a brilliant epidemiologist. Just now we are writing a review for diabetology on this. So what they showed in Pima Indians, because the population undergoes oral glucose tolerance test every 2 years, from 5 years onwards of age. So everyone in the population has an oral glucose tolerance test every 2 years after you become 5 years old. Therefore, they are able to trace a whole lot of things. What they found was that if the mother had diabetes in pregnancy, her children had a higher risk of obesity from very early life, which continues into later life, compared to mothers who develop diabetes later on or mothers who never develop diabetes. So according to the genetic theory, those who develop diabetes later on must be carrying the genes, but it was manifested later on. Interestingly, they did not increase the risk of obesity in the baby. Only those mothers who had diabetes in pregnancy increased the risk, indicating that it was intrauterine hyperglycemic environment which drove obesity in Pima Indians. And out of this and other work came the famous Pedersen-Frankel hypothesis, what's called fuel-mediated teratogenesis. And that indicates that in a diabetic pregnancy, mother transfers lot of extra fuels to the baby. That stimulates the pancreatic insulin secretion, which is a major growth hormone in utero, so makes the baby fat at birth, so there is macrosomia. It also produces neonatal hypoglycemia because that pancreas doesn't stop working quickly. And finally, interestingly, they said they went on to become obese, impaired glucose tolerant and diabetic in later life. And this is how he extended the term teratogenesis to include long latency, late manifestation diseases. Otherwise, for you, teratogenesis is a congenital abnormality. He said there was a congenital metabolic abnormality which manifested later on, and therefore he called it fuel-mediated teratogenesis. So we are now learning that life can only be understood backwards. So if you are a good history taker, you will do much better as a doctor. Today we hardly allow time for that. We just want to quickly get control of his symptoms, and we are bombarded in meetings like this about so many agents, and we treat them. So that is the principle of DOHAD, developmental origins of health and disease. This came out of David Barker's work. Fortunately, I was really lucky. In February 1991, he came and met me, and in 20 minutes my whole life changed. From being an adult diabetologist interested in gestational diabetes, I became more interested in intrauterine growth in undernourished mothers as a precursor to diabetes. And I drew this figure sometime 10 years ago to show what the idea is. It says it's the mother's influence on intrauterine environment which causes epigenetic changes, which reflect in fetal growth, development and differentiation, birth phenotypes. The crudest of that is birth weight, low birth weight, high birth weight, but so many other things can be measured. Then there are postnatal influences of environment, and finally we start seeing either the risk factors, so if you study long enough, you will see the disease manifestations. So pregnancy becomes an experience for two. So if mother is diabetic, the baby is also diabetic in pregnancy. Can you tell me a situation where it can be an experience for three? Not the twin pregnancy. Great, very good. So female fetus carries all the ova which it carries for the rest of the life at the time of around 20th week of gestation. So when a mother is pregnant with a female fetus, there is the grandmother, the mother and the grandchildren in the pregnancy. And that is a unique model which nature has developed to see the effect. If you see an association, what you will say, you will say it's genetic. Actually, it's driven by epigenetic factors. And that led to the concept of programming, whereby we say an adverse influence in utero changes the structure and function so that it remains with you for the rest of the life. And there are windows which are important. It has genetic and epigenetic mechanisms. Whole lot of environmental factors influence it, including nutrition, metabolism, stress, pollution, you can think of anything. And it could be multi-generational like we just now saw. But unlike, that's why I disagreed with Dr. Makkar and Ajay Kumar, that this might be reversible. So if this susceptibility develops that time, it might be reversible unless purely Mendelian genetic type. So we are concentrating on fat. Do you know that human baby has the highest body fat percent in the whole nature? It's not pig, it's not elephant, it's not sea whale. So the big animals actually have small percentage. is the small 2-3 kg Indian baby, not Indian, human baby, which has the highest body fat percent. There must be some interesting reason for this. That's why probably I got interested in this very much. And then the famous thing which happened as a student, and after reading all these things, I realized the patient in my clinic was very different than the patient described in the book. And when I went for training abroad, I realized the difference was obvious. And that's how I studied 100 patients in Pune, 100 patients in Oxford. And this idea came that we developed diabetes, or we are diagnosed 10 years younger at a BMI which is at least 5 units smaller. We have small mid-arms, we are thin in the limbs, but we have central obesity, and we have higher adiposity measured as body fat. So that for each kilogram weight or a kg per meter square, Indians carry 20 to 30% higher body fat percent. So I look thin, but when you compare with John Yudkin, both of us had identical BMI. My body fat percent was 21%. His body fat percent was 9%. And today I'm not going to tell you, but it's unspeakably high. So if you were to pour a fat dissolving substance on me, I can tell you 35% of my weight is going to dissolve. So it's that high. It's really bad. And then we showed that actually including the cord blood concentrations of leptin were high, insulin was higher in insulin bodies, and adiponectin was low. So what we talk in 40, 50-year-old as increased diabetes risk by measuring this, or device terms like pre-diabetes, is present there. And then we are trying to fight with the whole tsunami or whatever we call it in the adults. And then people usually don't believe the anthropometric measurements. Address Pune, India is not Mass General, Boston. So you have to then fool people by doing black box investigations. So you use MRI. And MRI even surprised me. We did MRI of newborns in 30 babies and showed that their all abdominal fat compartments were higher than English babies. And that's how the concept of thin fat Indian baby came. And these babies track their fat as they grow older. I've shown here up till 6 years, now we have data till 20 years. So this is comparison with English babies. We are tracking with high fat as we go along, and that's why there is an intrauterine origin which we are carrying with us. What influences the composition? We saw this slide before. It was the overnutrition of the fetus from the Norbert Frankel, and that was his slide, Soryale. In our pregnancies in Pune maternal nutrition study, where mothers were only 42 kg with a body mass index of 18.1, still her glucose in very normal levels, her cholesterol and triglycerides influence baby's size and adiposity. So it's the maternal transfer of nutrients to the baby which makes the baby. It's obvious. Baby is an entire parasite on the mother. So it gets all its nutrition from the mother. And then we also showed that an imbalance between micronutrients, so that if mother had a low vitamin D, low B12 but high folate, that baby was more adipose as late as 18 years of age. And if mother had low B12 and high folate, that baby was also more insulin resistant. And in an epigenetic study, we showed B12 intervention modifies methylation of genes involved in obesity and diabetes. So this is one of the very nice stories which we have developed. We also treat diabetes women in my clinic. We have more than 1,500 on our list now. We have followed their children, 200 here as part of a PhD, and offspring of diabetic children as early as 10 years of age, 24% of them were overweight obese, but at the same time 15% of women who were not diagnosed, which means the whole epidemic is now spreading. And interestingly, The most obese babies should have been type 1 diabetes mothers' babies because the control 20 years ago was very poor. Interestingly, they were not. So it means that mother's size also is an important characteristic there, and therefore we developed this complex figure broadly saying that it's the mother's as well as father's size and glucose seem to influence either the weight and adiposity related characteristics or hyperglycemia. So children of type 1 mothers have high glucose, but they are not obese as children, while the children of GDM and type 2 mothers are both obese and hyperglycemic. And therefore we are able to now separate out the effects, and we are studying the genetics and epigenetics of this. I'm not going to much into this because I am really not knowledgeable, but the mesenchymal stem cells ultimately give rise to the fat cells, the muscle cells, the bone cells, etc. And that is where a whole lot of activity is. And most of our adiposity is deposited in second trimester. So the baby's fat deposition is mostly in the second trimester, third trimester only it grows big. And various epigenetic mechanisms are involved, so you can study methylation, you can study histone changes, you can study miRNA changes. We have a whole lot of studies going on in our cohorts on these measurements. And I'm just going to tell you one exciting paper which came from our collaborators in Southampton, that they showed methylation of a gene RXR, which is a co-transporter for the transport transcription factor, in cord blood is a strong predictor of increased obesity in the child. So if you are epigenetically modified in utero, as evidenced in the cord blood methylation changes, your risk of obesity as child is very high. So I'm going to stop here, but what I have told you is that what we see in front of us in adults is usually present for a long time, though not obvious to the eyes. Obesity and adiposity are different, and these both conditions, including diabetes, are also programmed in utero in addition to the direct Mendelian genetic effects which we have. And therefore the unique opportunity for us as a public health problem is to treat and maintain good health of adolescents. If we improve their health, that graph which was showing increasing obesity or diabetes across the world might show a dip after 1 or 2 generations. Thank you.